How many times have we heard the word AI today? How many times have you used AI today? How many times have you used the cloud? Your phone's doing it right now, even if you're not asking it to. But just as you heard, AI is a hungry being. And so we think about this topic. Every time we're lazy and we ask ChatGPT the question instead of Googling it ourselves, what's the impact? And that's what we'll explore together. We'll look at these two elements. First, what is AI? If it's not already clear. And then what is circular? We'll put the two together. AI as we use it today, though, we're really talking about a small subset about the original definition of artificial intelligence, which of course started quite a while ago. If anybody can be brave and loud, who is this? Alan Turing. And which decade did Alan Turing coin the term artificial intelligence? 50s, yes, the 50s. And what's always funny about time is whenever I give this talk, I say about 50 years ago, Alan Turing was 70 years ago is when the 50s was. So Alan Turing developed what is called artificial intelligence in order to crack the German Enigma machine. There's a lovely movie about this. But that was the original term AI. What it really meant at the time was doing math faster than a human could, which is a big deal because every single day they tried to crack a code and it was a race against the clock. So here we have the first building block as we start to explore AI, because as a supply chain professional, I think about AI in terms of a self-driving supply chain, a self-healing supply chain, a supply chain that operates itself. And this is, I think, given the front page of all the exhibitioners out there, we're aiming towards an agentic operations future. And in order to do that, we need to put these building blocks together. So the first one is machines that can think faster than we can. And we have additional building blocks. We have machines that can see. We have a connected enterprise, and we have a fizzy-digi system. What are all of those? Machines that can see, this is in the 70s. In 1974 was the first time a barcode went beep. And the beep was on a pack of Wrigley's gum. Why does this matter? When we're sitting in supply chain at the time, we were doing everything by hand on paper. For the very first time, we were connected to point of sale with that very first barcode beep, thanks to GS1. Walmart was the first to connect that to the warehouse. First one, starting to connect point of sale to the rest of the supply chain. This is a huge deal. When we want the supply chain to run itself, the supply chain has to be able to see what's happening throughout the process. Connected enterprises. Now, this is a funny one because, of course, in the 1990s, this is the advent of ERPs. Have they proven it? I know SAP is a sponsor, so we're going to say, of course they have. But many of us still struggle with ERPs today to truly connect. Why? We acquire companies, we spin out companies, we mash companies together, we allow autonomy to some factories to pick their own stacks. All of a sudden, our one connected enterprise still needs some connectivity across, but that was the 90s. At the time, of course, nobody had a way to have the enterprise talk to each other. The early 2000s brought something pretty incredible for our global operations. This is RFID. The transformation that happened in ports specifically, in order to have the benefits of the beep of the barcode without having to actually scan anything. Then we get into, and this is the implications of each one, of course, as they come into our supply chain so that humans don't have to do it. That becomes a transfer of a human activity to a machine activity. I started my career in 2008-09 at Microsoft, and I remember a hallway conversation when we were still in the office then. We were all in Seattle, of course, and I remember us saying, gosh, Amazon is hiring all these data scientists into their supply chain. That's so weird. I wonder why they're doing that. And of course, we now know why. If we think about the world that Amazon has created for us, this is from their data science team, we start to look at terms that now are more familiar to us as we start to look at predicting what's going to happen throughout our supply chains, throughout our procurement processes, what our customers need, what our suppliers are going to do. What I love about this is it says in 2013, there was a lot of excitement around machine learning and deep learning. And of course, when we say AI today, most of the time we actually mean deep learning with a little bit of Gen AI thrown in there. We'll talk about that more. But what's great here is it says, 2013, we were thinking about this concept of a neural network, but it wasn't a reality. And then a group of interns between 2014 and 2015 helped make that into a reality. And of course, that's the basis of today's capabilities. This started the probabilistic predictions that we need in order for our supply chains to run themselves. So all of this takes us up until very recently when, no shock at all, and what's on the next slide, our whole world's changed. And our world's changed because of three major breakthroughs. One, large amounts of access to human language called the internet in every different language. That's one major step forward. The second is transformer neural networks, a new kind which work differently and help data relate to each other in a new way. And the third is purpose-built hardware so everything can go really fast. And it has gone fast. This is, in fact, 2 years out of date, but it shows you how these large language models and foundational models have developed. What I particularly like about this is the naming convention, some Berts and some Ernies up there, and all the different names we're giving to these models. What this means for us is we can talk to our supply chains. We can understand, we can search our supply chains in natural language like we never have before. We never have to log in to an application again, which is sort of awkward for some software companies. You think a lot about a user interface and the importance of navigatability of an application. But this becomes a reality. Here becomes the building blocks of AI. And if we think about the speed, this is a little bit small, so I'll pause here. The speed, which feels very fast to me, it is 70 years, but when we think about the size, the machine that Turing built in the 50s was called ACE. It took up a whole room. That got smaller, refrigerator-sized, and so forth, and now is the size of a postage stamp. We can look at compute getting much faster, moving from operations per second to teraflops. Memory, of course, has improved. Power has become astonishingly more efficient. And most importantly, the cost per MIPS, million instructions per second, the way that we measure how fast they can think, started out at $1 billion and now is down to fractions of pennies. So with this type of advancement, we're sitting here today with the ability to use technology like we never have before. And I'm sure at every stage in this history, supply chain professionals, or whatever they were called at the time, transportation analysts, had the same thought. What an amazing time to be in our field, to have access to the technology that we do today. We've all seen some version of this, but again, as a reminder, when we say AI, truly we're talking about a subset. Most often today, we mean some version of a large language model combined, perhaps with an agent or two, and that is a subset. That's deep learning and Gen AI. So AI, again, was doing math faster than a human can. Machine learning recognizes patterns without us telling it what pattern to look for. Deep learning looks at layers and layers of patterns. It might say something like, look at an image, and how do you know that it's a cat and not a witch or a broom? How do you recognize shapes on shapes and make sense of that? So image recognition, language recognition, all are examples of deep learning. Gen AI, we all know, we get to make funny memes and good pictures and send them to our friends. If we start looking at this in an example, we can think about a project manager, something we've all probably done in our careers and asked for budget to hire in our teams. But instead of a project manager, let's make her digital. An agent, let's say a digital coworker, or like I call them now, my colleagues in the cloud, which I think is a fun way to say it. And we might consider some of the tasks that she does in her day. Schedule meetings, take notes and set of action items, create our project plan, a critical path, conduct risk management, so as a risk to that critical path, and of course, manage our stakeholders, very fickle. If we take just one example of how we might schedule a meeting and break apart those tasks in a way that we can explain it to a computer, it might look like this. We need to be able to access schedules. We need to be able to request flexibility if one of the people needing to be in the meeting is not available. And we need to create an agenda. Doing all of these can be an example of machine learning. I like this version of the graph of machine learning because it shows us the 3 different versions. We've got supervised, which I think we're all familiar with, unsupervised, and then, of course, reinforcement learning. This might be an example of unsupervised learning when we think about a certain team member really prefers meetings first time of the day or in the afternoon or not on Fridays. These personalized experiences, we can now learn and alter our processes to help. So when we start to think about how might a process end, is it going to be an email or a text message or a Teams or a Slack message? And now the answer is all of those can work. So we think about the capabilities needed for AI, and in this case, I'm calling AI self-driving supply chain the pinnacle at the moment, the best we can consider an operation that runs itself. But as a supply chain professional, of course, I think about AI and remember that AI is in the cloud, and the cloud is a physical place. The cloud is made up of physical hardware that needs power, it needs to be cooled, and it needs to be maintained. So here we come to the second part of our question. We've said, okay, what do we mean when we say AI? And now let's look at what do we mean to be circular, and can AI be circular? Every single year, 100 billion tons of materials enters the global economy. It's a little bit hard to read, so I'll read it for you. Purple is mineral, orange is ores, blue is fossil fuels, and green is biomass. Along the top, we have the processes take, process, produce, provide, and we see societal needs at the edge. Housing, communications, mobility, healthcare services, consumables, and nutrition. Most of that is used or added to stock, like buildings, and you'll see a small feedback loop at the bottom of resources that are used again. What's interesting here, out of all 100 billion tons that come into the global economy every year, they come through you first. All of this is procured, all of this is sourced, all of this comes through our supply chains. That means we have some level of custody over these materials at some point in time. But of course, you've also probably seen that we use more than our fair share. Those 100 billion tons is more than we really can support as an overall planet. And when we say that, we mean we're actually running out of materials in the planet. This is some research done that is a heat map on the periodic table of elements. The darkest blue is less than 50 years of known mineable materials inside the planet. Now, there might be a case that we find more, but at this point in time, this is what we know that we can come and take. And that includes gold, silver, tungsten, tin, some of the big, important minerals that we need to run our technology and the cloud. So if we're using more than we can, and we're running through our supplies faster than we are able to, then we start to imagine a world where we actually need to regenerate. We need to leave the place better than we found it. So as we come into a process, to an industry, to a region, to a certain supply chain, how can we actually add to the stock? And we'll talk about that now. So how can AI ever truly be circular? And we'll look at these 4 elements like I mentioned before. How do we build, how do we run, how do we cool, and how do we maintain? Let's start with maintain. As I mentioned earlier, the rate of technology of hardware, of course, is advancing like crazy. This is why we see a chip war, and this is why the valuation of these companies is so high. Today, when we get a new server, typically what happens is we take the old server and we put it into a big industrial blender, throw some magnets at it, try to pull out the valuable bits, and we throw the rest away. We do that because it's hard to take it apart, and it's hard to wipe clean of data and reduce the risk to the company who's providing the server. However, we can use a very interesting application of AI here in order to reuse components. This is a company out of Washington, D.C. called Molg, M-O-L-G. They have developed a series of robots that can take a server apart in 3.5 minutes, which I think is an impressive feat. And they do that very specifically to put it back together again. They can co-locate this process, so they can take it apart, They test what they need to test. They replace the items that have become more efficient. So with how fast these hardware is developing, it might be that one server can now do the job of 10 servers. So this is, in theory, a good thing that we're upgrading the capability of these servers, and then they can remanufacture all in the same line. They've recently announced a partnership with AWS, so the good news is probably the hyperscaler solution that you're using is engaging in some version of how can we be more responsible with the hardware that we have. This brings up the idea of urban mining. You've probably heard of e-waste. Recently, I saw a study that estimates there's 10 billion phones in our kitchen drawers at home, not on the planet, just literally in our kitchen drawers, in that junk drawer we all have. And so we have this idea of mining cities, and it turns out it's actually cheaper to mine a city than it is to mine the planet. This is some research I actually did myself a couple years ago when I worked at 0100, and it shocked all of us. We checked the number several times, but really what happens is that the gold, for example, is more dense in urban waste, if you will, than in the planet. We can combine that with a solution like this one. This is Xometry. This is their homepage. You go to their homepage, and you can access their factory of 10,000 or their network of 10,000 factories. You upload a CAD design. You can see the toggle at the top. Do I want to have low volume or high volume? And if it's low volume, because we just need one replacement part for one server, you can do that. They'll find the factory closest to your operation that does what you need, and it'll produce for you. So in this way, we're talking about all of the physical materials that support this area. And in that way, we both maintain and build new. There's a lot of discussion now about reshoring. Some industries, particularly semiconductor, will be very difficult to put the whole thing into one geography. A chip crosses 70 borders before it's ever put in to the product it'll live in. But I do see a future where we can remanufacture regionally and locally. Then we need to run and power these data centers, and as you heard, they're very hungry. Very interesting organization called Breakthrough Energy, run by Bill Gates. They invest in breakthrough energy investments. Here's some examples of those investments they've made over time. You've probably heard of some of these, ranging from fuels to alternative energy production. In this case, I'll give you an example of what's called deep sky. Now, taking carbon out of the air is a very contentious topic somehow. Typically, though, we need to have ands, not ors, when we think about our solutions. So if we think about alternative energy sources and we remember our digital project manager, for the simple task of scheduling that meeting, that will take the same energy as 3 hours of a light bulb or charging your phone 2 times. So now, in a similar way that in our heads and in our guts we can come up with a cost per unit, we'll start to develop an energy per task, if you will. So we need to run these and we need to cool these. So the same idea for scheduling that meeting, it would take about a water bottle's worth of water. It's usually water used to cool these machines, which is why you see some of the innovations of putting data centers on ships or underwater, because there's a lot of water that's cold. In our case, if we take a standard data center, it's the equivalent of 6,500 households amounts of water. So what are we going to do? Because it's funny that they're putting data centers into water scarce areas, and then water's going to become even more scarce. So we can turn to some innovators, of course, in this space. As we start to understand the coming together of supply chain and urban planning in many ways. You may have seen of this innovation of pulling water straight out of the air, which is really interesting when you think about the air. So we can pull carbon out of the air. One of my favorite material alternatives, you actually do pull carbon out of the air and then ferment it like yogurt, and it makes a complete protein. It was how NASA was going to feed all of the astronauts up in space, and that's a reality today. It's called air protein. So we can take carbon out of the air to fuel. We can take carbon out of the air to make my earrings. These are 20 flights each earring. And we can take water out of the air to run our operations. Very interesting to watch the space. And we can start thinking about localized resource sourcing. So we get to our question here, can AI ever be truly circular? And it's interesting because we have all of the components. All of the technology actually exists already today. What we don't have is a shift away from the last 100 years of running our supply chains and those 100 billion tons that enter the economy every year through all of us. So we start to imagine a world again where instead of using more than the planet has, we make the place better than we found it, so that we still have resources to use 20 or 30 or 40 years from now. Now, I'm not sure how far all of you are through your career, but there's going to come another generation of supply chain professionals not so far after us who then have to deal with the decisions that we make today. 100 billion tons comes through you every single year. That means the decisions that you make a difference. So thank you for being considerate in the decisions that you make. And go be curious. This doesn't have to apply to AI and circularity. This could apply to any process that you run. You can go be curious about what it takes to run your process and the impact of your decision. Thank you very much.